Hello everyone and welcome to today's tutorial on the kinematics of motion for O-level physics. In the last tutorial we discussed distance and displacement. If we recap in short, distance is the total path length traveled by an object in any direction, but displacement is the straight line path length traveled by an object in a given direction. Distance has only the magnitude, it has no direction. That's why distance is a scalar quantity, but displacement has both of the magnitude and the direction. That's why displacement is a vector quantity. Today we will study speed and velocity and we will see how they describe the motion. Okay, let's start. First up, speed. Speed is the rate of changing distance with time. It tells us how fast an object moves with time. The mathematical expression for speed is distance over time. The unit of speed will be meter per second, that is the SI unit. But common alternatives include kilometer per hour, mile per hour, etc. Actually, the unit of speed depends on which unit you choose for distance and time. If you choose kilometer for distance and hour for time, then the unit of speed will be kilometer per hour. Again, if you choose mile for distance and hour for time, then the unit of speed will be mile per hour. The important key points you must keep in mind. One of them, speed is a scalar quantity. We know that speed depends on the changing rate of distance. As distance is a scalar quantity, so speed will be a scalar quantity. Again, distance could never be negative. That's why speed also could never be negative. It has magnitude that is only positive or 0. Now let's move to the velocity. Velocity is the rate of changing displacement with time. It tells us how fast an object's position changes and in which direction. So the mathematical expression for velocity will be displacement over time taken. And the unit of velocity is similar to the speed, that is meter per second, kilometer per hour, mile per hour. When we are using meter for distance and second for time, then the unit will be meter per second, and kilometer per hour when kilometer is the unit of distance and hour is the unit of time. Again, mile per hour when mile is the unit of displacement and hour is the unit of time. For velocity, there are some important key points you must keep in mind. These are: velocity is a vector quantity. As you know that velocity depends on the rate of changing displacement, as displacement has both of the magnitude and direction, that is vector quantity. So velocity will be ultimately a vector quantity. And we know displacement could be positive, it could be negative, and it could be 0. That's why velocity is also could be positive, 0 or negative depending on the displacement. If the displacement point is positive with respect to the starting point, then the velocity will be positive. If we return to the starting point, then the displacement will be 0 and velocity will be 0. Again, if our end point is reverse with respect to the starting point, then the displacement will be negative. For this case, the velocity will be also a negative value. Now we can determine the speed or velocity from distance versus time curve. the speed at any point of distance versus time curve is exactly equal to the slope or the gradient at the corresponding point. Say for if we want to determine the speed at the point A, so this value will be the gradient of this point A, that is the y displacement over the x displacement. Here y displacement denotes the distance and x displacement denotes the time. So here speed will be y displacement, that is 200 meter, and x displacement, that is 10 second. So speed will be 20 meter per second. As it is a straight line, and we know that for a straight line the slope is constant, so each and every point of this curve the velocity will be 20 meter per second. As here velocity is constant, so we can say that this straight line curve for distance versus time will be a uniform velocity, uniform speed or velocity curve. Again, if the distance versus time curve is not a straight line, then the velocity at different point will be different. Say for at point A, the velocity is to be the gradient of this point, that is the y displacement over x displacement. Here y displacement is almost 9 and x displacement is almost 4, so it will be around 2 meter per second, 9 meter and 4 second. But at point B, the velocity will be the gradient here, that is similar to the ratio of y displacement. Here it is 50 meter and x displacement it is almost 9 meter, 9 second. So this value will be 5 point something meter per second. So we are observing here the velocity of this non-straight line curve is different at the different point. If the respective points tangent is steeper, then the value is greater than the others. Here the tangent of this point A is less steeper than that of the B, that's why the velocity at point A is 2 meter per second, that is less than the velocity of B, that is 5 meter per second. Now we will solve a mathematical problem. Question is that calculate the speed and velocity for a car traveling to the east for 60 meter and question A returns 40 meter to the west in 20 seconds. Question B returns 80 meter to the west in 40 seconds. So for first case, what is the distance? We know that distance is the total path length traveled by an object. Here distance traveled by the car first is 60 meter, that is to the east, and 40 meter, that is to the west. So overall distance is 100 meter and time taken, that is 20 seconds. So speed will be overall distance 100 meter over time taken, that is 20 seconds. So speed will be 5 meter per second. Now what is the displacement? We know displacement is the direct distance from starting to the end point. We can visualize this mathematical question given that the car started from point A and it traveled 60 meter to the point B, that is at the east direction. Again, for question A, this car has returned 40 meter from the east to the west and at the point of C. So ultimately the distance from A to C, it will be 60, that is west to east, minus 40 meter, that is the return distance. So ultimately the displacement will be 60 meter minus return displacement, that is 40 meter, that is 40 meter is equal to 20 meter. So velocity will be displacement 20 meter over time taken 20 second is equal to 1 meter per second. And we know that velocity has both of the magnitude and the direction. Here magnitude is 1 meter per second, but what is the direction? If we notice here, then we will see that the position of the end point at the east from the starting point. So the direction will be to the east. Okay, for second case, what is the distance? Distance will be ultimately the 60 meter traveled first plus next 80 meter. 80 meter is equal to 140 meter. 140. This is the total distance and time taken, that is 40 seconds. So speed will be 140 over 40 is equal to let me calculate it. 140 over 40 is equal 3.5, that is 3.5 meter per second. And what will be the displacement? Again, if we look this, the car has traveled 60 meter to the east at the point B. Again it returned by 80 meter to the point D. So ultimately the displacement will be the distance between A to D. It will be 60 meter, that is A to B displacement, minus 80 meter, that is the return displacement. So overall displacement will be minus 20 meter. So for second case, the displacement is 60 meter minus return distance, that is 80 meter, is equal to 20 meter, and sign is negative. This negative sign means that the end point is opposite to the starting point, that is the end point is the west with respect to the starting point, and displacement is 20 meter and its position is west. So what will be the velocity? It will be the total displacement, that is 20 meter over time taken 40 second is equal minus 0.5 meter per second, and its direction is to the west. Now we will study speed and velocity side by side to see how they are similar and how they differ. First one, speed is a scalar quantity, is a scalar quantity, and velocity is vector quantity. Speed depends on the distance but velocity depends on displacement. Speed has magnitude only. It has no direction. But velocity has both of the magnitude and direction. If direction changes, then speed will not change. But if direction changes, the velocity will change. The unit of speed is meter per second, kilometer per hour, mile per hour, etc. And the unit of velocity is also meter per second, kilometer per hour, mile per hour with the direction. Okay, that's all about speed and velocity. In the next tutorial, we will study acceleration in details from the basic to advanced level. I will look forward to seeing you there. Thank you to stay with me.